Next, as we stroll down our little talk about geometry and some basics of geometry, we talked about triangles last time. Triangles have three sides, triangles have three angles, and they're kind of one of the most basic of this category of things called polygons. So polygons, what a polygon is a polygon. It's my first blank. It's always fun to fill in the blanks. Polygon is a closed figure. Remember when we talked about triangles, we dealt with the idea what closed means. Closed means it starts and stops in the same place. Okay, there is a whole geometry of open figures. That is not anything that we are going to be concerned about right here. A polygon is a closed figure in a plane determined by three or more line segments. So also polygons do not have curvy sides. Again, that is a whole nother idea of geometry. So we're just kind of sticking to the most basic things. If all the sides of a polygon are equal, the figure is called a regular polygon. So if you're given the detail somewhere, and that will come into effect on some problems we do on the second and third page here, but if you're given the additional detail that a polygon is a regular polygon, it means all the sides are the same, and thus all the angles will be the same as well. And that will be an attribute that we take advantage of that fact of a little bit later. So just kind of for your edification, I don't require that you know all of these. So if any of these words come up on my math lab as you're doing your homework, just use this as a reference. I've just put here in a little table some of the more popular names for some polygons based on the number of sides. That's generally how you refer to a polygon. And we talked last time about triangles. Tri means three. Also, angle means angle. But the rest of these are named according to their sides. A quadrilateral, which we're going to focus on a little bit in just a bit. Quadrilateral prefix quad means four, so that's something with four sides. A pentagon is five, the prefix pent. Hexagon is six, heptagon is seven. My favorite one to say and to spell is nonagon, meaning nine sides. So that's kind of fun. But those are just kind of some of the more popular or commonly used or commonly drawn of our polygons. So that's informational only. You don't have to memorize that chart. What you do need to be aware of is the different categories of quadrilaterals we're going to talk about. So quad means four. So there are basically five kinds of quadrilaterals that you'll see in this class. There are others, but these are the ones you'll see most of all. So the first one that doesn't really fall, it falls kind of outside. The other four are all related. The first one is what happens when you have two sides parallel, but you can notice from the picture, the other two sides are not parallel. They go in different directions. A figure like that is called a trapezoid. And we will talk about in coming sections how that relates to area, how we find the distance around it. These other four are all kind of related. In fact, all four of these are examples of what is called a parallelogram. And what is the unique attribute of a parallelogram is both pairs of opposite sides are parallel. And the corollary to that is both pairs of opposite sides are of equal length. So you can see in the picture that is a pretty typical looking parallelogram. The top and the bottom are parallel. The top and bottom are also equal length. Same thing, left and right are parallel. Left and right are equal length. That is what's called a parallelogram. And so now if we do some special things to our parallelogram, it gets called something different. So for instance, if I take a parallelogram and instead of having just obtuse and acute angles, if I make all the angles of a parallelogram right angles, then what you get is called a rectangle, which I'm sure you have heard that word and you've used that word before. A rectangle. A rectangle is just a parallelogram that has all 90-degree angles. Going the other direction, if I take a parallelogram and instead of worrying about the left and right and the top and bottom having different lengths, if all the sides have the same length, you get what's called a rhombus. So what's a rhombus? A rhombus is a parallelogram and all the sides are equal. So again, if I take a parallelogram and I make all the angles equal, you get a rectangle. If I take a parallelogram and I make all the sides equal, you get a rhombus. And then if I do both of those things, if I take a parallelogram and make all the angles and all the sides equal, well, then you get our good buddy, the square. So a square is just a particular kind of parallelogram. A rectangle is a particular kind of parallelogram. A rhombus is a particular kind of parallelogram. But all four of these things here are parallelograms. Now, you can't go the reverse. A parallelogram is not a square, okay, because a parallelogram is a very general feature. You might get asked something like that on the homework, so I just want to make sure that you are aware. Are we so far so good? Everybody got all the words written down? We doing fine? Okay, so you have to know those words just to the extent of we are going to talk about in the next section finding areas of different things. So you just have to know what we're referring to when we're finding different areas. All right, I'm flipping the page here. So the first characteristic of our polygon that we are going to talk about is what's called the perimeter. Does anyone know what the perimeter is referring to when I look at something? Yeah, if you walked around, if your property was a particular shape and you were building a fence around the outside, that is the perimeter of something. So the definition here is the perimeter is the sum of the lengths of the sides of a figure. I don't think you should memorize any sort of formula for perimeter, although some books give you formulas for things. All you have to remember is perimeter is what you get when you add up all the sides. Okay, so just keep that in mind as we're going through. So I've got my first example right here. Example 1, we've got a trapezoid right there, and we're going to find the perimeter. Now, the letter that designates the perimeter that we're going to use is probably not going to be any sort of big mystery. We're going to use the letter P for perimeter. But you're going to help me here because I've given a drawing that has some extraneous information, just because I want to make sure that we're keyed in on what perimeter is. What lengths am I going to add up to find the perimeter of this trapezoid? Okay, so we're going to start with 16 inches on the top, and then what? Okay, one of those sides, 13, and then 6 is the bottom, according to the way that's oriented. And then finally, 13. Yes. So the extraneous information is 12. We'd use 12 in a different situation when we find the area, but we don't have to worry about that right now. 12 is not one of the sides. Notice that line is dotted. That is indicating that that's a distance. It's telling you how far apart or how tall that trapezoid is. Okay, so it's not one of the sides. So now you grab your calculator. 16 and 13 is 29. Plus 6, that's 35. Plus 13, that's 48. And so we've got 48. And then something key to remember is perimeter is just a length. Okay, so your units are just going to be the units that are there. Okay, so it's 48 inches all the way around that trapezoid. Questions, comments, concerns about finding the perimeter of something? We doing okay? All right, well then the next exercise is yours. Exercise 1. I'd like you to find the perimeter of that rectangle. All right, when I go to find the perimeter of this, what am I going to add up? 8 plus what? Great, I'm glad you said that. One thing that sometimes students do in a problem like this, since it's not labeled, is forgetting that the bottom is 8, so that means the top is also 8. So don't forget that you have to add each of the sides twice, because you got to go all the way around the figure to find the perimeter. So the right side is 4, so that means the left side is going to be 4. So it's 8 feet and 8 feet, that's the top and the bottom, plus 4 feet plus 4 feet, that's the left and the right. And so when I add that up, what do we get there? Is that 24? And the units are feet. Units are important. Don't forget your units. Don't leave it off. On my test, there will be a deduction. If you just write down 24, I'll give you the bulk of the credit for knowing what the perimeter is. That's better. But the units are also part of this. Okay, so make sure you're including those. Exercise 2. If you got a question, ask it. If not, do exercise 2. Find the perimeter of that. All right, so my perimeter, here's what I'm hoping you did. If you did something different, let's talk about it. Let's be on the same page, because this is all I'm going to talk about as far as perimeter is concerned, because all it is adding up the sides of whatever the figure looks like, however many sides it has. So the perimeter of this one is I'm just going to start with the top is 5 inches, and then I'm going to go clockwise. So then plus 25 inches, plus 19 inches, and then plus 25 inches. So I'm going to add up those 4 things. You're welcome to use your calculator. So I get, let's see, 25 and 25 is 50, 55, and then plus 19, that's 74 inches. Any questions about perimeter before I go? I don't want to move on too fast if you've got something that you need to talk about. Okay. Well, then the next topic, and I think it's the only other topic in this section. I might be wrong on that. I typed up these notes a long time ago. Yeah, this is the last topic in this section, is the angles of a polygon. Now, last time we were together, we talked about the angles of a triangle. And before I started the video, you all reminded me that every triangle, no matter what shape it is, has the sum of the angles of 180 degrees. So then the question is, can we determine the sum of the angles of other figures? So what we're going to do is we're going to use, and we've used it before, and we're going to use it again. We're going to use a little bit of inductive reasoning here. Inductive reasoning, remember, means I am going to look for a pattern, and I'm going to make a general statement from that pattern. What I'm going to do is I'm going to draw some figures, and you're going to help me. You're going to help me determine if there's a relationship that we can determine. So, for instance, here's a 4-sided figure. Okay, this figure right here has 4 sides. I've drawn a rectangle, but it doesn't matter if it was a rectangle or something else. So I've got 4 sides. Here's what I'm going to do. I know that a triangle has 180 degrees in its interior angles. So I'm going to take a meat cleaver and I'm going to slice this rectangle into 2 triangles like that. All right, well, each triangle then has 180 degrees. So this triangle up top would have 180 degrees. This triangle down at the bottom would have 180 degrees. So how many degrees would you guess, if your life depended on it and you had to tell me a hypothesis, how many degrees do you think are in a 4-sided figure? 360. And I'm just going to write that as 2 times 180 degrees because there are 2 triangles. But yes, 360 degrees, perfect. All right, well, let's level up. Now, instead of 4 sides, let's do something with 5 sides, a pentagon. Okay, so here's a pentagon. My pentagon looks kind of regular with equal sides. Again, doesn't matter, but that's basically the extent of my artistic ability. So you gotta deal with that. So again, what I'm gonna do is I'm gonna take this pentagon and I'm going to divide it up into triangles. So notice I'm going to just pick a vertex here. I'm going to pick this one, and I'm going to start at this vertex where my pen is, and I'm going to draw a triangle. So I got 1 triangle right there. When I go over to that vertex, I've got another triangle. How many triangles am I able to divide that pentagon up into? 3, right? So I've got 5 sides. That means I have 3 triangles. So the number of degrees in that pentagon would be 3 triangles times 180 degrees. I'm going to do one more drawing. not to bore you, but just hopefully so that we can see the pattern. And then I'm gonna ask you what pattern that we may or may not see here. So we did 4 sides. There were 2 triangles. I could split that up. 5 sides. I could split up into 3 triangles. Now I'm gonna do 6 sides. I'm gonna do a hexagon. Again, it's gonna be a regular hexagon. That doesn't matter. It's just the best I can do when I draw. I'm going to pick a vertex of that hexagon and I'm going to divide this up into triangles. And as I'm doing it, I just want you to notice and tell me how many triangles can I make out of a hexagon with 6 sides? So when I have 6 sides, how many triangles am I able to divide that up into? 4. And so if I asked you how many degrees are in that hexagon, then you would say, well, since, oops, that's not the word sides, that should be triangles. I was doing so good too. So since I have 4 triangles, the number of degrees is going to be 4 times 180 degrees. So here's what I want to do. I'm not going to do the drawing because I don't even think I'm capable of it, but let's say I was able to draw something with 10 sides. Let's follow the pattern now. Here's the inductive reasoning. When I had 4 sides, we were able to divide it up into 2 triangles. When I have 5 sides, I was able to divide it up into 3 triangles. 6 sides, 4 triangles. How many triangles? What's the relationship there between the number of sides and then how many triangles I can make? It's always 2 what? 2 less. So if I said a 10-sided polygon, and I was then going to make it into triangles, how many triangles do you think I could make out of that? 8. Yep, 8 triangles. Okay, so you just used inductive reasoning. Very good. You just followed the pattern. And so if I then asked you how many degrees does a 10-sided polygon have, you would say, oh, that's 8 times 180 degrees, and we'll figure that out in just a minute. But here's what I need you to remember, okay? This will come up on your homework. It's going to come up on the test when you take it. In general, the sum of the measures of the interior angles of a polygon with n sides, now it's just n for number, okay? Just whatever number. We've done 4 and 5 and 6 and 8. Is going to be like this. And I'm going to write this below the blank because I've kind of made a big mess of my space there. So it's going to be n minus 2. So you take the number of sides minus 2, just like you told me a minute ago. The number of triangles I can make is 2 less than the number of sides times 180 degrees. That's always the pattern. No matter what polygon you are looking at, the sum of the angles on the inside will always be n minus 2, sides minus 2, times 180 degrees. And the reason I go through this whole process is you can see why we multiply by 180 degrees, because it's the number of triangles that we split that figure up into. So I'm going to flip the page. Exercise 3 is a super straightforward example. I want to know what is the sum of the interior angles of an octagon. Now, if you don't know how many sides an octagon has, flip to the front page. Okay, I gave you a little chart. It'll tell you. So from our inductive reasoning, we can say this, that the answer to this is going to be the number of sides minus 2 times 180 degrees. Okay? How many sides does an octagon have? 8. Okay, so that is going to be 8 minus 2, or in other words, 6 times 180 degrees. And when you throw that down into your calculator, how many degrees are, if I add up all the angles, would I get? 1080? Great. Now, At that point, I can't do anything else because you could have something that has 8 sides and the sides don't have to be the same length. They don't have to all have equal angles. So you can't divide that up anymore. The last problem we're going to do is I'm going to throw in one more detail. So I've got a problem and you've got a problem, both with this extra detail. So given a regular hexagon, now just to test our short-term memory from the front page, what does the word regular mean when it's referring to a polygon? Equal sides and equal angles. Okay, so I'm giving you an added detail so we can have a little bit more fun with this problem. So I'm going to do my best attempt to draw a regular hexagon. A hexagon has 6 sides. So here we go. It's got 1, 2, 3, 4, 6. Oh, that is actually really lovely. I did a pretty good job. But just in case anybody would quibble with me, I'm going to make the little mark so that you know that I intended to draw a regular hexagon right there. Okay, so remember those little marks. We talked about this with triangles. Those little marks mean that I'm telling you that those sides are equal. Okay, so now we're going to do this problem. The first part of the problem, in fact, we didn't need the picture for any part of the problem. I just wanted to illustrate what's going on. The first part is just what we did a second ago. Let's find the sum of the interior angles. Okay, well, since a hexagon has 6 sides, that is going to be 6 minus 2 times 180 degrees. And when I go into my calculator and multiply 4 times 180 degrees, I get 720 degrees. Are you with me so far? Have I done anything confounding? Okay. Now this next part requires it be a regular polygon, okay? Otherwise we couldn't do this next part. But what we're going to do now is we're going to find the measure of each individual angle on the inside. Okay, so I'm going to find the measure of, let's just say, I'm going to put an arc here. I'm going to find the measure of that angle. Well, since it's a regular polygon, does anyone have a proposal for how I would do that? Perfect. Yes. If each of these angles is equal because it is a regular polygon, then that means the degrees are going to be equally distributed among each of the angles. So I'm going to take, just like I was told, the 720 degrees, and I'm going to divide it by 6. All right, and when I do that, let me grab my calculator. Here's my good buddy, the calculator. 720, I'm going to divide by 6. I get that each angle is 120 degrees. Everybody tracking with me? You see how I'm able to determine that? All right, one more thing, this is also part of the fun. I have one of these on your test, so you can put a little asterisk by it. You're going to do this exact same process on the test you take whenever that is coming up in the future. The last thing is, let's find the measure of an exterior angle. Well, this is the reason I drew the picture, is I just want to show you what an exterior angle is because I haven't defined it. An exterior angle of a polygon is if I take a side and I extend it. So I'm just going to draw a dotted line right here. That forms, can you see that dotted line on the overhead up there? Okay, great. That forms right here. This is an exterior angle. Well, this is a nice review problem. This is the reason I like this problem. It just incorporates something we've already talked about. We get to bring it back to the forefront. Does anyone have a thought on how I can calculate how much this exterior angle is? Perfect. Well said. I'm going to take the interior angle that I just found out what it was, which I'm just going to write right here, 120 degrees. Okay, we've just found out that that's 120 degrees. And the exterior angle, the way I defined it, is it's just creating a straight line right here. And so exactly what I was told is, okay, if that's a straight line, then that adds up to 180. So the 180 for the straight line minus the 120, that's the interior angle, is equal to 60 degrees for the exterior angle. So just a cute little problem that I enjoy. So if you would, please, I'm going to give you a minute or two. Exercise 3, just repeat those 3 steps. I didn't write the A, B, and the C, but just repeat those 3 steps for a dodecagon. And just to save you the the hassle of going to the front. A dodecagon is 12-sided. All right, so on the page is my best attempt to draw a dodecagon. It's a little bit elongated, but I did okay. I'd give myself a C+ on that right there. That's why those marks are important. So don't ever assume, a figure is regular unless you're either told it's regular or you see the marks. One of those two things. Don't make assumptions. So here we go. First thing is, I'm just going to write the letter A here. What's the sum of the interior angles? So I'm just going to go through the work. If you did something different or you got something different, let's chat about it. So that is going to be 12 minus 2 times 180. 12 minus 2 is 10. 10 times 180 is 1,800 degrees is the sum of all the interior angles. The B part, since I told you it's regular, we can find the measure of each individual interior angle. That is going to be the 1,800 divided by 12. And does that turn out to be 150? Is that what that is? All right, great. Without a calculator, I am eating it up today. Great. All right, 150 degrees. And then the C part is then, okay, if I know this interior angle is 150, what is this exterior? And that is just going to be a quick mental calculation of 180 minus 150 is 30 degrees, the exterior angle. Before we're done with wrap this one up, any questions, comments, or concerns? All right, well then we are shutting down the video.